In this video, we are going to take the completing the square skill that we have learned and practiced and use it to derive the quadratic formula. So starting with a standard form of a quadratic equation, so ax squared plus bx plus c equals 0, I'm going to use the completing the square concept using these coefficients. So our first step that we did is to group our variables. Then I need to make sure that the leading coefficient is 1. So in order to do that, I need to factor out an a. So when I factor out an a, I'm left with x squared plus b divided by a would just be expressed as a fraction, b over a, x plus c. So then I can complete the square, the process. So I'm going to take my b coefficient, or this second coefficient, b divided by a, and I'm going to divide it by 2. Now when I do this, this is the same as when I'm dividing by a constant. It's like multiplying by the reciprocal, or keep, change, flip, which would allow me now to have b over 2a. So all this step here is taking this middle coefficient and dividing by 2, which from complete the square we know helps us find out the term or the number that this factors to. And then I need to square this. And so when I do this, I end up getting b squared divided by 4, because 2 squared is 4, a squared. So this is the term, or the number you can think of, that we have to add in order to get a perfect square trinomial here that factors down to this. So if I am adding b squared divided by 4a squared inside this group, I'm going to have to subtract it from outside the group in order to maintain balance. However, this a coefficient means that I have to multiply this term by a, making it a times b squared divided by 4a squared. And so in order to simplify this, what you would do is I have essentially a number, c, and then subtracted by a fraction. And so what I need to do is get this c expressed as a fraction with the denominator for a squared. And so to do that, I'm going to multiply c by 4a squared over 4a squared, which simplifies to 4a squared c divided by 4a squared. And now I'm just going to rewrite this next term. This gives me common denominator, so that I can simply subtract my numerators and keep my denominator. And so here we have a very convoluted vertex form of our standard equation. So now I'm going to solve as if I was solving with numbers. And so when I do this, I would subtract all of this on both sides, so it would cancel out on the left-hand side and would leave me with a negative 4a squared c plus ab squared, all divided by 4a squared, and I simply got that by subtracting this. You'll notice how when I subtract, both of my signs switch when I'm moving from the equals on either side of the equal sign. And so now I'm solving for x. So in order to do that, I need to divide both sides by a. This once again is the same as saying that keep, change, flip. So dividing by a coefficient or dividing by a constant a is the same as multiplying by the reciprocal 1 over a, which would give me a negative 4a squared c plus ab squared all over a 4a cubed. Now I can simplify. There's a lot of exponents, a lot of variables here in this fraction that I can simplify. So when I do that, I'm going to simplify and factor an a out from each term, because that's the common variable that's shared, or coefficient. So that would leave me with 4a times c plus b squared all over 4a squared. And so when I rewrite this simplified line, I'm going to write it where it's b squared minus 4ac. And the reason for that, one, because it looks familiar. So we're getting to a point where we're looking more like the quadratic formula. But it's also because I'm going to take this positive and put it out in front and so that I'm not dealing with too many negatives. So once again, I'm trying to solve for x. So my next step here is to square root both sides, leaving me with just x plus b divided by 2a. And then when I square root this fraction, it is like I'm taking the square root of both the numerator and the denominator. So that leaves me with the square root of b squared minus 4ac, all divided by, now the square root of 4a squared simplifies to 2a. And now in order to solve for x, I simply subtract a b over 2a from both sides. And when I do this, I'm left with x is equal to an opposite b over 2a plus or minus. Now that is something I forgot. I want to make sure we reiterate. When we take the square root of both sides, we end up with a plus or minus. The square root of b squared minus 4ac, all divided by 2a. Now you'll notice that I've split this up into two sections. This is our quadratic formula. So this entire process of completing the square has led us to a formula that you've already learned. So the reason I have this split up, that I don't have it all expressed, is when you have to simplify, you can easily see how to simplify both this first opposite b term and then the discriminant, or what's under the radical. So what this also shows us is we have a opposite b over 2a is the axis of symmetry of our parabola. So in our parabola, the x for our vertex is also called our axis of symmetry, that line. And the second part represents the distance from the axis of symmetry to the x-intercepts. And then the radicand, or what's under this radical, or what's under the square root, is called our discriminant. So in a previous course, you knew that the discriminant can kind of clue you in or tell you the nature of your roots. So whether you have one real double, two real roots, or two imaginary roots based on the discriminant. This whole piece, the discriminant along with this divided by 2a, tells us the distance from the axis of symmetry to the x-intercepts. And so that's actually, this distance helps us to see why the nature of the roots actually occur. So we're going to take this quadratic formula and apply it to some practice problems, but if you were ever curious, this is how you derive it. And take a deep breath. You will never do this again, I promise.